Hello everyone, welcome to Computerized Engineering. In this video, we will make this part. And the main purpose of this video is to have a look at how we can connect two faces using multiple guidelines. For example, I have this top face over here and a bottom face over here. And to connect these two faces, I made four guidelines. So the first one here, the second one located over here, the third one is here, and lastly, the fourth one is located over here. Now, if you're familiar with SolidWorks, you might know it's quite easy to do this, but unfortunately in FreeCAD, it's a little bit complicated, but don't worry, I have prepared a small presentation that I will walk you through. First of all, we will create the sketch, then one by one, we will have a look at each option, how to connect these two surfaces using guidelines. First of all, we will have a look at additive pipe. Then you will install a new workbench, which is called CurvedShapes workbench, and we will have a look at how we can use this tool to connect these two faces. Then we will have a look at surface fill boundary curves, and lastly we will have a look at how to assign thickness when the thickness tool fills. So without further ado, let's get started. Now, if you're a beginner and if you're wondering, how is this a beginner tutorial? This seems too advanced for me. Well, you have to start somewhere if you want to create a complex shape like this, and I think this is the perfect beginning for you. So let's start with a new empty document. Let's click here, empty file, tasks, create body, create sketch, and let's begin our sketch on this plane. Now, let's start with this ellipse over here, which has dimensions of 75 and 40. So for that, click here and go to create ellipse by center and draw an ellipse like so. Let's assign the dimensions. So this one is 75 and this one is 40. Press escape to exit from this dimension. Click here and change this to construction geometry. Now there's one thing you have to make sure, that the sketch you make, it's in 4 different segments. So the first segment, second, third, and fourth. And in order to do that, let's go to this option, create arc of ellipse. Click here in the center and then click here and then click here on the top. Now when you drag your mouse like this, you can see you're drawing an arc of an ellipse. Now similarly, repeat this process again for this side as well. You can see when you drag your mouse and you click here, now you have the second segment. When you're doing this, make sure you see this crossover here, which means that your ellipse is snapped to the center. So again, let's do this, the third segment, and lastly the fourth one, like this. Press escape to exit from this. Now we can see that our sketch is under constraint. Let's see what's the problem. Okay, so let's drag all of these one by one, and yeah, you will see 1, 2, 3, 4, 5 lines over here. Select all of them and then select this axis and then choose this constrain horizontal / vertical. Now you can see your sketch is fully constrained. Let's exit, and now let's proceed with this top sketch over here, which is 100 millimeters above. So for that, let's click on this eye icon over here so that we can view the origin, and then go to this option, create a datum plane. Choose this as your reference, and in attachment offset, change the set direction to 100 millimeters. Make sure this is in the correct direction and press OK. Let's hide the origin and the planes. Click here and begin your sketch, create sketch. And similarly for the circle over here, we will create this in 4 segments as well, and later you will know why this is necessary. So change this to create circle by center and give this a diameter of 30. Press escape to exit and click here, change this to construction mode. And now choose, let's choose this option, create arc by 3 points. Now similarly, we will create a circle in 4 different segments. Now let's constrain this, choose this point and this axis, choose this point and this point. Let's make them vertical, and similarly for this point as well, this one and this one. What's left? Okay. Okay, this is over constrained. Let's press Ctrl Z and let's do something alternatively. Select these two, make them equal. Yeah, this is good. So close this. We have both of our sketches. Let's hide this diagonal plane. Now let's proceed with the guidelines over here. So let's create this one, which has a radius of 355, and it's identical on both sides, but you have to make sure that these are sketched separately, not in the same sketch. Let's view the origin and let's choose this plane because these guidelines are on this plane. So click here, begin your sketch, go to model and hide the origin, and choose this option, create arc by 3 points. And in order to snap this, press escape and go to this option, create external geometry. Click here and click here. Now you can see you have these reference guidelines over here. Go back to this option, create arc by 3 points. And now you can see this X symbol has appeared and you can easily snap this arc. So snap it here and snap it here. Now give this a dimension of 355. The sketch is fully constrained. Let's close it and do the same thing on the other side as well. Choose this plane. Let's hide the origin. Create reference over here and here. Choose create arc by 3 points. Snap it on this point and this point. Give this a dimension of 355. Okay, so far so good. Now we have just two more guides remaining. So first let's create this one, which has a radius of 300. Let's choose this plane, begin your sketch. Let's hide the origin and create reference over here and here. Snap your arc here and let's zoom in a little bit here. And this has a dimension of 300. Okay, now let's proceed with the final guideline. Now this is a spline and let's see how we can create this. Choose this plane and begin your sketch. Let's hide this and come back to tasks over here. Now in order to create a spline, you will choose this option, create B-spline. Now before we begin, let's press escape and create reference here and here. Now let's go back to this option and snap it here, press somewhere over here and then again here and then snap it here. Now you can see you have press escape. Now you can see you have 4 points over here and press escape again. Now what you have over here is a B-spline and okay, this is disconnected. Let's connect this first. Choose this point and then choose coincident. Again for this point and this point, make this coincident. Now what you have over here is a B-spline, and now let's give it some dimensions. So this point over here and this point, these are vertical, and so is this point and this point over here. Now let's assign rest of the dimensions. So this one is 80 millimeter from the bottom and this one is 30 millimeter from the bottom. So from here till here this is 80 and from here till here this is 30. So our sketch is fully constrained. Let's exit. And now we are ready to begin with the real part. Now, first of all, let's have a look at, before we proceed, let's rename them so that, you know, it's easier for me to refer. So let's change this to base. Let's change this to top. And let's call this one front guide, this one back guide. Let's call this left guide, and let's call this right guide. Okay, now we are good to go, and let's have a look at additive pipe. Now this option is available over here. Click here, additive pipe, and first you have to select an attachment. Let's start with this one, base. Okay. And in section transformation, change from constant to multi-section and click on add section, then click here, and you can see now it says stop over here. And in the path to sweep along, let's choose this one as our path. Now you can see it's not very perfect, but we can change this a little bit, and for that go to section orientation and change this to auxiliary. Click on add edge and then choose this edge. Now the problem with this option is that first of all you can see it does not follow this perfectly, and secondly it's not suitable for multiple guidelines, which means that you cannot choose multiple guidelines over here. You can only choose one, and even this one is not followed perfectly. So let's cancel this. Let's have a look at what we can do alternatively. Now the second option is curved shapes, and in order to begin, first what you have to do is install this from the add-on manager. It's very simple. Go to tools, add-on manager, and here just type curved shapes. Click here and install this. I have this already installed. It's very simple. Once you install this, you will have to restart FreeCAD, and once you have done that, you will see curved shapes over here. Now assuming you have this installed, let's go here, curved shapes. And before we begin, there's just one thing we have to do. Go back to part design model, and we have to create just one more sketch which will be a reference. So click over here, origin, so that you can view the planes. Let's choose this plane and begin our sketch, and just create one line over here from which is snapped from here till here, and let's give this a dimension of 100. The sketch is fully constrained. Let's exit, and let's call this reference. Now let's go to curved shapes, and in order to use this option, what you have to do is first of all select the base or the top where you want your sketch to start. In our example, let's start from base, and then select reference, front guide, back guide, left and right. Ignore top, and then click here. Now you can see you have some sketches over here, and we can modify this. Click here on curved path array, and let's change the number of items to 20. Now when you view it, you can see it follows this guide perfectly from both sides. And you can convert this to solid if you just scroll down, click on solid and change this to true. Now you can see this is converted to solid. Now the advantage of using this option is that it's relatively easy to use and it follows the guidelines perfectly. But the disadvantage is that it's not suitable if you have different shapes on each side. For example, if you have something rectangular over here and circle over here, then it's not suitable to use in this scenario. Let me show you an example so that you can visually see it. Now at the base, this is not an ellipse, it's sort of a rectangular shape, and you can see the difference over here. And if I choose this as the starting point for the curved path array, then you can see that the base we get is an ellipse, and you can see the difference over here. So this option is not suitable if you want to strictly follow the shapes on each side. So instead, we will have a look at this option, Surface Fill Boundary Curve, which is more suitable for complex shape and you have more control over surfacing. However, it requires specific sketch. For example, just like we made the sketch in 4 different segments, we did that specifically for this option. And additionally, all these faces will have to be converted to solid. So that means there are more steps involved, which I will walk you through. So let's get started with this option now. Click here, press delete, and click on this eye icon because we do not need the reference for the second option. Now you have the surfaces workbench installed by default on your FreeCAD, so just click here and then choose this option, fill boundary curves. Now in fill type, make sure you have cones selected. Click on add edge and let's start from the front. Select these 4 edges and you can see it follows the guidelines perfectly. Press OK. Let's hide this and we have to repeat this 6 times because we have 6 faces to create. Now the back side, make sure the add edge is selected. Okay. Okay, now we just have top and the bottom left, and for that we can leave this as stretch because this is a straight face. So add edge, select all these edges. Okay. Now you can understand why we created this in segments. Add edge. Okay. Now click here and press shift, then click here, press spacebar. Now you can view all of the 6 surfaces, and once you have that, you have to install a new workbench. For that, go here, Tools, Add-on Manager, and here search Curves. Now you have to install this one, Curves Workbench. Now once you install this, we will choose this option, Parametric Solid, to convert this to solid. So just click here, install this. Once you have this installed, you will have to restart FreeCAD again. So once you do that, you will see Curves Workbench over here. Go to this workbench, select all of these surfaces, and then choose this option, Parametric Solid. Once you do that, you will see a solid has appeared over here, and in shape status, you can see solid. Now, it's possible that you might get a brown solid over here, and in shape status, it will say surface. So if that happens to you, there's something wrong, but if you follow this tutorial correctly, you will get solid over here. Now that's the end for this slide over here. Now let's have a look at how to assign thickness when the thickness tool fails. And for that, let's go to part design and model. First, let's choose this option and quickly run check geometry to make sure everything is okay. We can see we have 0 errors, and in settings we have all of these options selected. Now it's possible that this thickness feature might work or might not work depending on the complexity of your design. And if it doesn't work, it doesn't mean that you did something incorrectly. It's just that this tool is not very powerful when it comes to creating thickness. Now, before you choose this thickness option, just click over here on solid and drag this above until you see base feature where you are making your part. Now, once you do that, click over here and then let's choose this face and let's assign a thickness of 2 millimeter. Now you can see the thickness feature has worked perfectly okay for us, but let's suppose it doesn't work for you. What you can do is, let's cancel this and let's hide the base feature and view the solid over here. Let's go to this option, this workbench draft, and click over here on solid and then click here clone so that you can create a clone of this solid. And now what we will do is we will change the scale of this clone so that we can make a thickness of 2 millimeter. And I have the formula over here. I will put this in the description so that you can copy this. And let's just copy it and go to scale. In XYZ, click over here and then click here, enter an expression. Control V and let's change the desired thickness to 2 millimeter, and actually let's change this to -2, because we have to create a scale which is less than the original shape. Okay, now let's repeat that, but here we have to change this to y, change this to y as well, and the desired thickness -2. Okay, and for the last one, z -2. Okay, and now let's go to part workbench. Before we proceed, let's have a look. So you can click here and let me show this to you. You can see that we just have to change the placement of the clone. We have to move it 2 millimeters above from the bottom. So in order to do that, click here on your clone, and in placement go to position, and in Z change this to 2 millimeter. Now once you do that, you can see it has perfectly aligned and we get a thickness of 2 millimeter. Let's rename this and call this a scaled down clone. Now click on the solid and then press Ctrl to select scale down clone, and then choose this option, cut. Okay, this has given us an error. Let's change the refine to false. Yeah, now this is okay. And now if I just change the transparency, you can see that we have the thickness over here. The thickness does not seem consistent over here. It's narrow on the top here and wider at the bottom. So let's do a quick check by overlapping two geometries and just comparing them. So I will just quickly go here and change to part design workbench. Let's assign this, let's hide this, view this part, and give this a thickness of 2 millimeter. Let's change the transparency and view this part as well and change its transparency as well, like so. And let's change its color so we can view this. Now here you can see, yes, this method is not very reliable. The thickness at the top, it's quite narrow, and at the bottom it's quite wide. And if we see it from this side seems okay, except here at the top. So if you're going with this approach, make sure you verify that the thickness is indeed accurate. But in our case, let's proceed. Let's change the color back to normal. So appearance and default. Let's delete this. Now let's proceed with making the top part of the bottle. Let's change the transparency back to normal, and let's hide all of this. Now go to part design workbench and click over here, and then click here, create a clone. Now once you have a clone over here, just hide this cut, open this, and you can see you have a new body and a new clone over here. Now press click over here, create sketch, and this will ask you that to create a new part design object, there must be an active body object in the document. So select this one and press OK. Now you can just select this face. Okay, let me click over here and then begin the sketch. Yeah, now let's create a circle over here which has a diameter of 24 millimeter, and let's extrude this 10 millimeter. Okay, now click here again. Let's create a new sketch with a circle which has a diameter of 20 millimeter, and let's create a pocket and let's give this a length of, let's say, 20. Now you can see we have this hollowed part over here, and now let's proceed by creating additive helix over here. But first we have to create a sketch. So click here so you can view the plane. We will start from this plane over here. So begin your sketch over here. Let's create a reference geometry, and let me hide this now. Tasks, and click over here, toggle construction geometry, and then choose this option, create line, and just create a line and give this a dimension of 10 millimeter, and return from construction geometry to normal geometry mode. And let's create a line over here, and then choose this option, create arc by 3 points, and just snap your arc like so, and select this point and this line, and choose this option, constraint coincident. And then from this point until this point, let's give this a length of 1.5, and this one 1.5 as well. Now close the sketch, and while this sketch is selected, go to this option, additive helix, and change the pitch to 2 millimeter, change the height to 5 millimeter, and then check this box reversed. So okay, this seems okay. Click OK over here, and now we have the additive helix. Now let's just proceed by giving a fillet over here, and we have to make sure that we give a fillet here and on the inside as well. And in order to ensure that, go to view. Okay, first we have to cancel this. Now go to view and then choose this option, clipping plane. Click over here. Now you can view the inside edges as well. Now let's go to fillet and choose this edge, and this one, and this one. Then click over here, flip, and then choose these edges. Scroll down and let's change the radius to 3 millimeter. Press OK, and let's close this. Now this is the end for this tutorial. Now before I end this video, let's run a final check geometry on this part. So select this feature, fillet, and then choose this option, check geometry. And you can see that it says the solid is invalid and there are some Boolean operation errors. If I go to settings, uncheck this option and run the check again, you can see the errors have disappeared. Now here I want to mention that the Boolean operation check, this is a check which is a specific analysis tool dedicated to Boolean operations, and it is not a general validity checker for CAD models. And let me show you an example. I made this part some time ago in SolidWorks, and this was perfectly okay. But once I open this step file in FreeCAD and I run a geometry result on this, we can see this will give us some errors as well. Now this part was made in SolidWorks and it showed no errors when I made this in SolidWorks, but over here we can see again we get many Boolean operation errors. And if I go to settings and uncheck this and run this again, we can see the errors have disappeared. So just use Boolean operation checker to check the quality of Booleans only, and don't use this as a general validity checks. It doesn't work for that. So this is the end for this tutorial. Thank you for watching. Take care and see you in next video.